Today we're talking to Bharat Kadluri of Coinshala, and we're talking about a pretty simple thing actually. We're talking about what is blockchain. So tell me, Bharat, if you had to describe it to a child, a 6-year-old, a 7-year-old,
Yeah.
how would you explain what blockchain is?
So first of all, hello everyone. I'm Bharat. It's good to be here. So as you say, right, blockchain. Everybody is talking about blockchain. Blockchain this, blockchain that. I was just joking about blockchain, that blockchain can actually make sandwiches. Blockchain is used in washing machine. It's used in everywhere.
Yeah,
so people are speculating. Like
Everyone's got a new ICO.
So let's look at the technical aspects of it, how it actually works underneath, right? Why people have been so fascinated about it, why it's so popular, and right? So if you look at, right, it's block and chain, as simple as that, right? You have blocks, you have chains. How do you create a new block? You create a chain, you attach the block, and you have blockchain.
A block and a chain, and a block and a chain, and a
Yes.
block and a chain. All right. So we've got
So,
simple
okay.
bit.
So let's go more details into
Yeah,
it. So,
so-
what is this block? So this block could be any information, right? Any data, like for example your PDF documents, your text or images or any digital
Okay, so
content.
any data on
Any
your computer
digital
can be a
content
block.
Can be a block, right? Now what is this chain? So to understand a little bit of chain, you have to go into a little bit of technical things.
Okay.
But bear with me. I'll try to make it as simple as possible.
Okay.
So in computer science, or at least in cryptography, there are terms like a hash. If people would have understood what
You
a
mean
hash
like
is.
a hashtag?
Not hashtag. So hash is, okay, I'll make it very simple. So hash is like a function. Think like a tunnel, right?
Okay.
So you input something into the tunnel.
So
and
car goes in a tunnel.
yes, at the end of it, you will get a magic number. Okay.
Okay.
So a magic number is string. So that string is like a unique fingerprint, as you said, right? Car. So if you try to change a little bit minute details of a car, like color,
Yeah.
right? The fingerprint changes. Or if you change a mirror angle, right? A slightest, tiniest change will actually make you to change the hash of it.
Okay. So the hash is like the car's
Unique
identity.
yes,
Okay.
identity.
So it goes
exactly.
in. It goes in as a red Mercedes.
Yes.
And if it comes out as a blue Mercedes, the identity is changed.
Exactly. So how this will be helpful? So I'll take an example. For example, I want to deliver a package to you, right?
Okay.
So I courier it to you. How do I make sure that the package is not tampered?
Okay.
So I send it through a hash function.
I
I send
see.
the hash it to you. So that when the package arrives it to you, you will hash it and compare both the
Okay.
hashes. So that
you send the package through the tunnel, and you
Yes.
send the hash outside the tunnel.
yes,
And you look at both when you get the package. If it
Yes.
matches, it's the right package.
yes,
Okay.
that means the package has been not tampered.
Okay.
So let's come back to the blockchain. So here the hash is exactly the chain that connects both the blocks.
Okay.
So now let's go a little bit more detail. So how is it different? What is that value that is adding here? Fine, you have blocks,
Oh, you
you
can
have a
tell
hash.
exactly what package it is. Okay.
Yes. So whenever you want to add a new block to the existing chain, you would take the hash or the chain of the previous block and put it into the current block and add it to it.
Oh, okay. So what you do is the first block says, okay, my name is Bharat.
Yes.
And then you put a hash.
Yes.
And you send
no,
it.
you compute a hash out of that.
So that's a chain.
That's the chain.
So you create the chain, and it comes to the second block. And
Yes.
the second block, the first thing is the first block's hash.
Yes, exactly.
So under that you write, okay, my name is Bharat and I work for
Etc.
Coinshala.
Yes.
And then the
exactly.
second hash is generated.
Yes.
And that's a new number because now
Yes.
you've changed a little bit.
Yes, exactly.
So it's just making sure that the second block has the same
Depends.
information as the first block.
It depends on the previous block. So each block you add to the chain depends on the previous block.
Okay. So
So-
that's how you can tell where the block is compared.
Yes.
So if you find a random block, you go, okay, this hash number is the sixth block. So then this new block is the seventh block.
The beauty of this is that imagine if you try to tamper any one of the blocks data, that will change the hash of it,
Yeah.
which will change again the next block's hash.
So,
So the
immediately
entire-
everyone knows.
Every block has to be changed,
Right.
right? The entire hashes fail. So this brings the immutability part of it. So that means if you add something to the blockchain, if you want to change or tamper any contents, you have to change the entire chain. Okay.
So it's basically instead of today if you hack into a database, full
Yes.
of names, dates,
Yes,
whatever,
yes.
you can just change whatever you want, one thing, and go home. Now
Yes, if you have access
But if you
to it.
hack into a blockchain,
Yes.
you have to change everything, every block's hash,
Yes.
and that's the only way to do it.
And it adds even one more step of difficulty. So people would have heard about mining, right? Everybody says mining, I mined this many coins and etc. So mining at the end is a simple mathematical problem that whenever you try to add a new block, you have to solve it. So as you specified, right? So when you are creating the block, you add a content to the block.
Okay.
Along with the content, they add a magic number, a second magic number.
Okay, so you've got the block with whatever information.
Yes.
You've got one hash.
Yes.
And then you've got a magic number now.
Yes.
Okay, so what is this magic
number? So magic number is called, so people use the terms like proof of work or
right, different ways to mine.
Yes, mine, right? So what is this? So to attain this magic number, you have to spend some computational power.
Okay.
For example, a simplest example is if people would know about prime numbers, right? So you multiply two prime numbers, you'll get a composite number.
Okay.
And if you want to factorize the prime number, it is very difficult.
Okay.
So 3 into 5 is 15.
All right.
So trying to factorize, this is a simple example. Now verifying it's simple, like 3 multiplied by 5 is 15.
Correct.
But from 15 deriving 3 and 5, you have to be a little bit of
okay, so
trial
3
and
and 5 it's easy. But then if you do
a huge number,
3-digit prime numbers, then it's very hard to find the two numbers.
Yes.
Okay.
So people, what they try to do is they will try to solve a mathematical problem and then find this magic number and add to the block. That will make even difficult. So not only you have to tamper and rehash the entire block, but every block
magic number
everywhere. So that will take huge computation power.
So that's what, so basic. So when you're finding this magic number, you have to have whoever has the best computer will find it first.
Yes, exactly.
So that's why there's this whole thing about environmental problems and everyone buying bigger and bigger and bigger computers. Wow. Okay, it's all to find the prime number. Right.
So actually, if I that's one of the example. Actually, if you look at the consensus algorithm, so they have to find a number which has a certain bit of zeros, n zeros. So you have the data. You have to find a number such that when you hash the entire thing, you'll get a hash. If you convert into binary, the first n bits, which could be 70, 72 bits, have to be zeros. I know I'm going too technical.
So basically the magic number not only has to be, you find these two prime numbers.
No, prime number is an example of I gave.
So you have to, basically the actual way it works is you have to find a certain number with certain number of zeros in that number.
Yes. So when you convert into binary, you have, it has to be it has to have certain number of bits.
Certain number
leading zeros, it's called.
Oh wow, that's really so. If you're struggling to understand this, just imagine how hard it is to actually do it. All right, so now we'll
we'll talk about mining and proof of work in some
section. But for now, so now we've got the block, which has got the hash, it's got the information and the magic number.
No, I didn't even complete it.
Oh no.
Because if you see the entire blockchain or hash is in a single system or a single decentralized point.
Okay.
But in blockchain, the entire chain is replicated across all the nodes.
So every computer that's attached to the blockchain can see every transaction.
Has to have the entire blocks. So you not only have to compute the hash, magic number, and you have to replicate everywhere. So that makes it virtually impossible to hack.
So if I hack it, even if I buy the best computers and if I hack it, I change all of the hash numbers and I change all of the magic numbers.
Yes.
Everyone else will just say, no, that's wrong because my paper says these are the wrong numbers.
Exactly.
So that's incredible. There's no way.
So that brings literally immutability to the blockchain.
So you have to, the only way to stop that I can think of is if you bribe all the computers to say this is the right number.
Actually, there is a problem called 51% problem, where if you buy the 51% of the network, theoretically you can do that. That I believe it's literally.
So that's okay. I mean, imagine, just think about it. Number of people using coins today, using Bitcoin, using Ethereum. You have to pay off 51% of them, and only then can you hack something.
Yes.
That seems like a lot of money to waste. All right, so now we've got the basics, right? So we've got the block made of the hash, the magic number, and the content, which is secret or not secret, depending on the chain.
Yes.
And you've got the chains keeping the blocks together.
Yes.
So if you want to hack it, the best time to hack it is the first block. After that, it's just too hard.
Yes.
All right, so now we've got this. Now, obviously, we know for money it's good, right? So this way, it's a good way to make sure that the money I spent is actually being spent. I'm not just saying, oh, I paid 100 rupees to buy that food or that sandwich. I actually gave the 100 rupees. There's proof in the block.
So it's called the double spending problem. This common problem. So what you do is, if you look at the fiat currency, as you said, I spend $100, I get a sandwich. So I'm literally transferring the note to him so that I can't spend it again.
Correct.
But if you look at digitally, right, it's a number, right? I can actually change the number, or there's nothing like being spent.
Okay, so it's like, so if you use a card to buy the sandwich and then you hack into your bank account and say, no, I didn't buy that sandwich. So you get the sandwich and you get the $100 back.
Yes.
So on the blockchain, you can't do that because
yes,
too many things to hack.
Yes.
Okay. So now that's obvious. Okay, we've got money. Good. That's why there's so many coins, so many different currencies. But what else can you use blockchain for? What else has this problem?
So if you look at Bitcoin, it was solving a particular set of problem, which is the currency.
The sandwich problem.
Yes. So it has a limited data. So if you look at the block of the Bitcoin, you have the to and from address and the actual number. Right. Which is the currency, right?
Right.
So that Bitcoin blockchain is limited to that. So that was blockchain 1.0. So there was this next generation of blockchain, which are called blockchain 2.0, like Ethereum or Hyperledger.
Okay, so the new big guys will do something different.
So what they did, why not I put why am I putting simply a number onto the blockchain, right? What happens if I put a piece of code, like a contract, right? Okay. So then you introduce the concept of smart contracts.
Okay, so what exactly is a smart contract?
Okay, and I'll
okay, in a brief way, give me a couple of sentences.
So say both of us are there, right? Okay. So we don't trust each other.
Okay, so I want to buy a sandwich from you and you don't trust me.
I don't trust you.
Okay.
Because if I...
the last time I bought a sandwich from you, I went to change the number in the bank.
So if I want to buy something from you, right, I have to transfer it to you. Right. And I don't trust you because you won't deliver the goods to me. Okay. So how do we bring trust between each other? So
we get a friend. He will say, okay, I'll take the money, I'll take the goods and give it to both of you.
Okay, the friend is, is close to you.
No. Oh. I'm always going to choose that friend.
Or he is close to me and he maybe he's biased.
Okay.
Again, right? There's a problem there.
Right.
So how do we solve this problem? So we introduced something called a smart contract, which is a magic slate or a magic piece of contract. Okay. So where we agree to the terms into it. So I say, see, I have to transfer this much of amount to you the moment I receive the goods. Okay. So we agree to a contract, sign it, and put it in the blockchain.
Oh, so you can't hack the blockchain?
Once I put it into the blockchain, that's it. And you can have events or triggers to actually trigger the money. So once I receive the goods from your side, this will trigger events, and that will automatically transfer the amount of assets.
So it's like, okay, if Amazon was on blockchain and they come to your house and they come and say, okay, here's your package, please sign this. And when you sign it, then it's like, okay, I've got the product, so take the money on the blockchain.
So the smart contract actually transfers it automatically. Without the need of a third person, right?
Okay,
so it's like you write a piece of logic into the smart contract. Whenever I receive a certain goods or whatever, it will trigger a function that will actually transfer, so that both of us will trust the contract, not an escrow or a third party person.
Okay, so basically you just get rid of the middleman.
Yes.
There's no more middleman for anything.
Yes.
Okay, so that's...
So anywhere you need a trust, right, between two parties, you write smart contract, put it in the blockchain, and once we finish our negotiations or business, then the smart contract takes care of actually transferring the assets or goods and services.
That's amazing. So that's everything though. You need a middleman for everything.
Yes.
I mean, think about it. The banks are the middleman when you pay for anything with card. I mean, that's incredible. Okay, so we've got it. So that's, if you've been following along the video, which I don't know how you couldn't have been following, but blockchain is, well, it's a block. It's got a set of information. It's got the hash. It's got the magic number, and it's got everyone watching the hash and the magic number, which creates a whole set of stuff, which makes it impossible to, or near impossible to hack into. And with that, you can get rid of middlemen all over the planet. So that's, I mean, I can't get over how incredible that is. But that is Bharat talking about blockchain, and we'll see you next week for something else.